Hello everyone, and thank you so much for joining me for day 90 of 90 Days of DevOps here on Michael K's YouTube channel. Now it's an honor to present the final last day. There have been so many amazing presentations throughout this series, and I highly suggest you to subscribe to this channel and also check out the previous videos, the previous presentations. Now in this presentation, we're going to talk about why another tool might not be the best solution for your problems, for your technical problems. So this talk is titled Fighting Fire with Fire, where we cannot always prevent technical issues with more tech. Generally in tech, we have the tendency to just implement new solutions, new tooling to solve our issues, but it's not always the best approach. Who am I and why am I talking about this? My name is Anais. I'm the open source developer advocate at Aqua Security. I worked in between as site reliability engineer while working for the past 6 years as developer advocate. I'm also an ambassador of multiple different organizations, including Open UK, Grafana Labs, and I'm a GitHub star. You can just see here, there, the top of the star. Otherwise, I'm covering it up, but that's me. Now, if you know my content, you know that I love talking about tech and different tooling in the cloud ecosystem. But this talk is really not about that. I will apply the concepts introduced in this talk on chaos engineering, because I'm a huge fan also of chaos engineering. I've actually written my bachelor thesis last summer on applying security chaos engineering on containerized workloads. There's the link in the presentation, which will also be linked below or somewhere, the link to the presentation to my bachelor thesis. Otherwise, you can find my bachelor thesis also on my GitHub. Now, what else to expect from this presentation? It's really about how you can make the most and being any person within an engineering team, whether open source engineering team or within your organization, and how you can add value straight away independent of your skills and independent of the knowledge of different tooling. Generally, when we want to develop a new feature or fix a bug, we have to go through several different stages and plan basically what we want to do. In open source projects, we usually describe what we want to do, what has to be done in issues. Some people describe things in more detail, some people describe in less detail, but then we can go ahead and actually respond to it. Now, a lot of times, especially in organizations, we don't actually make the decision and document and plan first. So we have these two options. Either we document and we plan first, or we go ahead and we fix the issue, fix the bug ad hoc, or solve all problems ad hoc without actually developing a plan first. So the first path, let's build first. Let's respond to our problems with new technical solutions. Let's try to solve our problems without first documenting our problem. In short, a lot of times we have the tendency to want to automate and upgrade absolutely everything. And that could end up in our infrastructure looking a little bit like this, on having different building blocks that are all somehow connected, but we don't actually have a clear understanding of how they are connected. And in some cases, we have small dependencies that we are not even aware of. And that could be a project that has been maintained thanklessly by some random person in Nebraska since 2003. Or it could also be a package in NPM that is used by several other packages. And actually, by deleting this one package, this is how a programmer broke the internet. He deleted a package called leftpad. And it consisted of 11 lines of code, 12 lines of code, if you include the space. And that ultimately, because he deleted that project, it broke several other projects. Now, you can read about the full story online. Ultimately, he had a dispute with NPM and the company called Kick, because I had another project that was also called Kick. Now, the company Kick wanted to have the name. He didn't want to give them the name. NPM settled with the company, and in response, this programmer was very upset and deleted all of their NPM projects, including leftpad, and that resulted in the issue. Now, once that happened, eventually NPM undeleted the package, but it caused lots of issues and lots of confusion. And you want to be aware of all of these transitive dependencies, so these indirect dependencies. So why you might not use the project leftpad, you want to understand if you use it through any other project. Now, the thing is, when we get started developing new software, new tooling, we almost never know the functional and non-functional requirements of a system before we actually build it. That means even if we plan before what we want to do, new problems might emerge as we develop a new feature, as we work on our software, as we respond to a problem. And that's okay. That's foreseeable. The issue is if we don't have original documentation of what was the issue, what did we actually want to solve, we can end up over-engineering our project. Over-engineering is the act of designing a product or providing a solution to a problem in an elaborate or complicated manner, where a simpler solution can be demonstrated to exist with the same efficiency and effectiveness as that of the original design. The thing is, a lot of times we lose sight of our original design and the problems that we wanted to solve and just go ahead and fix things and add things, and that's how we end up in these situations with our infrastructure looking like like a kid's toy. Anyway, so what does our documentation actually look like in that case? I've come across lots and lots of open source documentation where we have different steps that you have to follow to, for example, set up the project. So you do step 1, step 2, step 3, and at step 20, step 30, step 40, you realize that you don't actually know why you are following these steps anymore. And that usually happens when the maintainers, when the engineers who wanted to tell you how to set up that tool just added things ad hoc of like, oh, and then we actually need this and we need that, and you want to make sure you have this installed and so on. And that makes it very, very difficult for people to actually follow what's going on and be able to set up your project in the most effective way. Now, I've picked here on Istio, this is a screenshot from their documentation just because I remember in the past it has had that style. Now, since they've changed a lot, so shout out to them. But that's ultimately what you don't want to have. You don't want to have these long steps where you don't actually explain what to expect and what to do and why to do it. Now, if that's within your team or within an open source project, you can really frustrate people. So people will look for documentation because they want to feel empowered, they want to feel self-sufficient, and they want to be able to identify what to do by themselves. And that can be, first of all, very time-consuming. Usually it doesn't take 15 years, but it can be very frustrating to spend an entire day just on trying to install a tool, and then you realize it doesn't work on your environment, for example, but that hasn't been documented. Another issue is if within your team you have more junior people or new hires joining and they ask you, okay, how can I actually get onboarded? Where's the documentation? How do you interact with your infrastructure, with your different environments? And the team lead is like, means it maybe even well, means it in the best possible way of just saying, hey, just ask me, I'm the documentation, I know all there is, just ask me if you need any help. And they mean it usually, again, in a very well way, in the most caring way possible, but it ultimately takes agency away from the people who want to get started with your tooling or who want to get onboarded. If a junior engineer has to ask you every time they don't understand something or they are stuck about how to do it, they can't actually get anything done by themselves. And that's a bit of an issue. Now, let's apply that a bit more on chaos engineering. Chaos engineering is the practice of intentionally injecting fault into a system to test its resilience. Now, in the case of Kubernetes, that could be, for example, us deleting specific pods for specific workloads to see, okay, how does our system respond? Now, if your pods are managed by deployments, so by replica sets, the deployment should realize, hey, there's a mismatch between the number of replicas that I need and the number of replicas that I have. And then the deployment is responsible for spinning up new pods. So within chaos engineering, we have to plan these experiments of forming a hypothesis. What do we actually want to do and what can go wrong? For example, in the case of deleting pods, if a pod is deleted or dies unexpectedly, then we expect the deployment that's connected to that pod to spin up a new pod. That would be hypothesis. Now, we want to contain the blast radius, and that means identify the workloads that we want to test, that we have tested, that we want to test in the future, that we're currently testing, and basically test the smallest possible blast radius and just identify, okay, this one workload, what happens in that? And then once we tested one workload, what happens if we delete multiple pods of each of our different workloads in our cluster. How will the cluster respond in those cases? Just as an example, so as you identify issues on a small scale, you then want to fix those issues and expand the blast radius on wider areas, more workloads, different resources. Now, as you can see, there are multiple different components, moving parts that play a role in creating actually chaos engineering experiments. Usually also a small team is working on a chaos engineering experiment. Now they want to also share with other people in their team, in their organization, of what they have already tested. If somebody leaves the organization, they want to be able to hand that over to somebody else. Somebody new wants to pick up where the previous team, the previous employee left off, and actually understand, okay, what has been tested, what has not been tested, where do we know we have issues, loopholes in our system, and we have to work on. Now, without documentation, the issue is with all of these moving parts, whether they're related to chaos engineering experiments or us just actually working on our tooling, a lot of times we actually don't really know what's going on. And that might be that we set up a new project. There may be duplicate projects within our organization that do exactly the same thing, solve the same issue, but they are set up independently, so two different teams maintain it, even though it's ultimately fulfilling the same goals. Then new people might join and leave. The security team might also have access to our cluster to patch CVEs, while another team decided, okay, they want to migrate their database to another cloud provider. Then we update dependencies, we upgrade our deployments, and so on and so forth. So there are multiple different paths that happen within our software project between human and machine interaction. Now, if people have access also to make ad hoc changes in your cluster, they could just modify your configuration files, modify your deployments with kubectl apply, and you won't have a trace really on what has changed, how was your deployment supposed to be described, supposed to run, and how does it actually run now. Now, if we have the state of our resources, for example, kept in Git, if we follow GitOps best practices or similar, what we can do, we can understand the history of the changes that have been made, versus if we just run kubectl apply, we might have logs of the changes that occurred, like audit logs or not. But ultimately, it's much more difficult to identify who changed what, where was it changed, why was it changed, how was it changed. And those are all questions that ultimately help us also to respond to an incident. So the second path, the path that I'm advocating for, is documentation-driven software development. Ultimately, we have two main goals: reduce costs for the business and increase revenue. Now, whether we're talking about security incidents or normal incidents, they cost money. For example, in 2017, British Airways had an incident that cost the company £80 million, which is a lot of money. All sorts of incidents, if they happen on your production tooling, they will cost you money, whether because it's your service that's down, or because you have a security issue and people then don't want to use your service, don't trust your service anymore. They will have a real business impact. Now, if you document your chaos engineering experiment, you document how you resolve those incidents where you try out different scenarios, then the people who are on call will know what to do, will know what processes to follow. So ultimately, besides knowing what to do, it will also empower more junior engineers. They will feel like they can ask for help in those situations where they need to. For example, if a mid-level engineer is on call, they can run, or they know which processes to run through and at which stage to call the help of a more senior person within the team. Now, if they don't have these runbooks, if they don't have anything to base their actions on, they might not feel comfortable to call a more senior person to the incident, especially if it's the middle of the night. So incidents, especially night incidents, will cost you money as well. Night incidents particularly, because nobody likes to be woken up every single night by an incident. And eventually people, very skilled people, also will leave, will be so frustrated. So we ultimately want to go from this situation to this. To this. So ultimately, we want to be able to fix our tooling. We want to be able to feel empowered to respond of like, hey, yes, we know what to do. And otherwise, we identify what has to be done. And then we share it with the team. And this is not just me saying it, but it's also coming from lots of different wise people. So this person, Nathaniel Swanson, said on a Datadog blog post, documentation is key. If those going on call know what to do with every alert they receive and how to get help when they need it, that will alleviate a lot of stress. So ultimately, you want to document what has to be done, when it has to be done, by whom. What are the different types of documentation that we can have? And that's not related to chaos engineering experiments or runbooks or similar, but just in general, we can have particular developer documentation and user documentation. Those are the two main documentation types. Now, developer documentation can be within your team, can be you maintainers within an open source project on how to use the tool, how to work with the source code, for example, how to work with your infrastructure. User documentation is, as it says, for users. Now, it can also be within your organization that you have users. For example, you might be providing services to other teams in your organization. So you're the developer, you're the team, and the other team using your services are the users. Now, you have to keep different things in mind. First of all, obviously, whom are you writing the documentation for? But also, what is their experience? What is the level of detail that they require to ultimately work with your documentation? Developer documentation, if you, for example, document how you migrated your database, it doesn't have to go into great details. You can assume an existing knowledge by other senior engineers, right, within your team. Then you also have to think about the stages when the product is supposed to be used. So, for example, is the user supposed to install the tool, or are there existing users who actually want to upgrade it or use your latest features? So what are the goals that your documentation is ultimately trying to reach? Now, in addition, you can also have blog content, how-tos, and other guides. These are usually types of contents that are very short-lived, so they easily become outdated. For example, tutorials on my own blog, I don't really maintain them. And I state that they are not really maintained. However, for example, the tutorials that we have on the Trivy documentation, those are maintained and updated over time. Now, generally, tutorials, how-to guides, and so on, they fulfill a very specific goal. They serve a very specific use case. So while documentation provides more generic setups, use cases are very specific scenarios. So, for example, describing a specific implementation. They are also usually created by individuals instead of a group of people or a team. So, for example, if I'm working on a tutorial, it's usually something that's done within a specific time frame by myself or a small group of people, versus documentation is usually maintained over time by multiple different entities. For example, before I joined Aqua Security, people were working on a Trivy documentation. Now I'm working on a Trivy documentation. People will work in the next years on the Trivy documentation. It might not be me. Who knows, right? So there's no clear time frame on when the documentation is kind of finished, right? Now, what are some of the technical solutions that we can use also for documenting? Well, there's CatchGPT, which basically is not a way to document, but to access kind of like hive knowledge of documentation. So CatchGPT is a tool for scanning your Kubernetes cluster, diagnosing and triaging issues. In simple English, it has SRE experience codified into its analyzers and helps to pull out the most relevant information to enrich it with AI. So you can, for example, document in which scenarios your users, your engineers are supposed to use CatchGPT. For example, if somebody is just getting started with Kubernetes, has their development cluster set up, they might get enough information through CatchGPT versus having to call the SRE team, somebody in the SRE team, while they could resolve it themselves by getting instructions from CatchGPT. That would be, for example, one use case. Now, over time, you can access different models in CatchGPT, where CatchGPT can basically pass in your error messages from your cluster and get information from. So it's a form of documentation because you access information on what to do. Now, there are also different documentation frameworks, and that makes documentation more generic. Documentation shouldn't look like how you would it like to look, but what's best and like what's defined as best practices within the industry. For example, looking at the Diataxis framework, that's one that we use at Aqua in the open source projects for Trivy and Tracy, or basically aim to model our documentation after. Also, KGPT's model after that, and Canonical does a great job in modeling their microkits documentation after Diataxis framework, and it divides your documentation in different components, different parts of it. Now, in chaos engineering, what do we actually want to document? As another example, generally when you run experiments, you have known knowns, so things we are aware of and we understand. And you want to document those because you want to share with other people, for example, new hires, and how the things actually work within your infrastructure. Then we have known unknowns, things we are aware of, but we don't understand yet. So we know, for example, that we have certain issues in our storage layer, but we don't know where those issues arise from. So we want to run certain experiments to understand those better, so those known unknowns become known knowns. Then we have known unknown knowns, and those are things we understand but we are not aware of. So if they come up, we would understand what we want to do, but we are not aware of that they might come up. And that's also why we want to run chaos engineering experiments. Now, the worst parts are known unknowns, which are things we are neither aware of nor understand. And this is kind of like the black box that we want to be able to open and move into unknown knowns and known unknowns and known knowns. So how do we do that? We actually have to gain first an understanding of the current state of things, the current state of our infrastructure. So we have to map our services, dependencies, both internal and external ones, and actually map what's going on. So we want to gain a picture of how is everything connected? How might one service and the failure in one service especially affect another? And once we have that map, we can plan our experiment. We can define our goals, development components, processes that we might want to follow during the experiment, the expected results and outcome, basically our hypotheses, and the factors that might affect our hypotheses. Now, different projects that you can also use as part of your chaos engineering experiments. In the CNCF, those are Chaos Mesh and Litmus Chaos that allow you to basically automate experiments and also write your own experiments. And then once you have run the experiment, it's really no use to run an experiment without having a post-mortem, and the post-mortem basically allows you to know which components have been tested and understand how to solve incidents faster in the future. And it's really a teaching opportunity. So basically, based on your post-mortems, you can share what has happened, how you responded, how you would respond differently in the future with other people in the team. They are allowed to and able to ask questions in those situations, so you can also enhance your documentation on resolving incidents or those types of incidents. Now, 2 projects that allow you to automate postmortems and much more. These are 2 paid projects, but you can use them for incident management as well as for documentation and creating runbooks and similar. Incident.io and Rootly. So check out those projects if you're interested. And then there's also a guide linked here on how to conduct postmortem reviews. Now, my main tip overall in summarizing what we have shared in this presentation, what I have told you so far, is you really want to start writing down what you're doing. And that's either if you work with your own home cluster, your home lab, or if you work with your organization's infrastructure. There's only value to be gained by taking notes and writing down what are the issues, what are you trying to achieve, especially when you get started with any of the tooling shared here in those 90 days. What is the goal? Why are you getting started with it? Why are you using those tools? What is the goal? What are the struggles that you had? Especially sharing your notes publicly can really help other people. In overall, summarizing, there is no right or wrong in writing. It's not like coding, developing software. You can always change things, right? It won't have any negative implications if you write things down wrongly. That's better than somebody trying something, a command that you have written down that worked for you in the past and then it doesn't work. Is still better than leaving people with nothing who might join your team in the future. So that's it for me. Thank you everybody so much for joining. Thank you so much for listening. You can find more content from me here at anaisul.com. Again, huge shout out to Michael Kate, the organizer of 90 Days of DevOps, for having me here. It has been a pleasure. I hope you enjoyed this presentation. I hope it was useful for you. I hope to see you on also my YouTube channel and other content, and hopefully sometime in person at a conference. Have an amazing day, morning, evening, week. Bye bye.